Srinivas says lots of data to process. Okay. Arvind says mechanism to store and process huge volumes of data. Okay. Anybody else? Yeah. All right. So Puneet says process high volumes of data. Jyotsna says analyze, process, and store huge volumes of data. Okay. Balaji says large and complex data. Okay. Good. Good. And Srinivas says lots of data to manage and analyze. Great. Great. So we have got good set of answers. Anybody else? Yeah. Puneet says, as you said, according to the previous history. Right. Right. Correct. Now, big data in very simple words, data of various size, a very high size. It's not tools, it's not technology. Big data simply represents data of very big size. Okay, very big. The definition could be very different depending on the structure, and we will talk about more how to classify a data as big data or small data. Okay. The second point in the definition is such a data you cannot process with usual tools. And for handling such data, you require distributed architecture. So the third point related to the distributed architecture is the most relevant of all the points. Fourth is structured or unstructured. So all right. So, in case you're wondering what is structured or unstructured, so structured means you know what the kind of data it is. Let me just, all right. So, never mind. So, what does it mean by structured and unstructured? In structured data, you know your input data very well. You know clearly that these are the records, and in the each record, these are my fields. Okay, so that is structured. And in the structured data, you also know the data type of fields. Okay, while unstructured data, you don't know in what format your input data is. It can be the plain text files, such as the logs generated by an application, or it can be videos, it can be images, that it could be in various format. All right. In structured data, the data is clearly formatted and easily parsable. Okay, meaning the data is passed and available to you along with name of the fields and data type of the fields. All right. So CSV file is the same structured because in CSV we know the columns but we do not know their data types. Data in relational database is structured because we know the column names, we know the field names, and we know the data type of each. So that's why it's called structured. All right. Now This is the formal definition of big data as given by IBM. They keep on adding V in this definition every year. And so these are nothing but characteristics of data that make a data big data. Okay. But the main definition of big data will remain as such. The definition is data of big size. When you cannot handle such a data using usual tools, you require tools with distributed architecture. Some of you might be wondering what does it mean by distributed architecture? Distributed architecture simply means a tool that can run parallelly on multiple computers. That is called distributed architecture. A tool that can run parallelly on multiple computers to solve your problems is a tool having the distributed architecture. All right. Any questions for me? No questions. All right. So the data could have high volume, such as the data at rest, which is already gathered from various sources, or data could have high velocity, such as the data coming to you from various website and the data which is moving. Third is the variety. The data could have humongous variety, as in some data could be in structured format, unstructured format, and by virtue of these three criteria of the properties of data, you might have you basically would end up using a distributed architecture. All right. So let's take one example where so volume, when we talk about, you can think about data is stored by Facebook. A lot of data every day accumulates. So that data is at rest now and is counted as volume. Now imagine that there is a website such as an analytics tool, or let's extend the example of Facebook itself. So in Facebook, every second people are refreshing every second and people are trying to see their updates. So there's a humongous velocity of requests that goes to Facebook every millisecond. So so this is velocity. There could be scenarios where the velocity is low, sorry, volume is low, but velocity is really, really high. Let's take a case. Have you ever used a website counter? A website counter displays the number of hits on your website. Okay. So imagine this website counter is a completely separate website and it's just providing you the counts. Every time a request comes in, it increases the count and displays the new value. That's all it does. Now, even if the website has a million hits, it is going to increase a single number, which is total number of counts so far. So there is no storage at all. There is only one number that is being stored. So the whole of the if you are keeping if you have a database, it will be empty. It will have just one value called total hits on your website, right? So it's just very small data. But if your website is having millions of hits every hour, then that means that a single computer will not be able to handle such a load, and you would require a distributed architecture to handle such a load. This is velocity. So by virtue of velocity alone, even though the data is small, by virtue of velocity itself, you can end up having a lot of requests, lot of data to handle, and effectively a distributed architecture. All right. Third one is variety. So, so variety Variety means there are two parts in variety. One is complexity of the problem. Okay, complexity can be in the form of your data is complex and requires a lot of parsing to understand the data, or complexity also means that the time taken to process your data, even if it is well structured, is going to be high. For example, if you have to find the clustering of lot of data, if there is a lot of data and you want to divide it into groups, your normal SQL queries will not be sufficient. The kind of problem you are trying to solve but because of clustering is really, really tough. It takes a long time to to do clustering on millions of records, right? So even if your data is small, even if data is at rest, and there is no velocity, there is no volume, and you only have variety, you can end up having a problem really, really complex that requires multitude of computers to solve your problem. Other would be the Google Map, the path searching in Google Maps. Okay, when you search path in Google Map from one point to another, it has to go through a lot of records, and it has to basically do a lot of work, lot of heavyweight lifting, right? Even though the size of the map data could be very small, but the time taken to solve the problem. So even if your map size is small, Google Maps, for example, maybe if for a city like Bangalore, the total data would be hardly 100 GB, hardly 100 GB. Okay, so to search in that 100 GB in real time quickly is going to take a lot of time. Therefore, all of these problems end up becoming distributed architecture problem, and hence they are the big data problems. So you can get your big data problem could be because of the volume of the data, velocity of the data, variety of the data, or veracity of the data. Veracity is something very, very abstract term. Veracity means the data in doubt. All right. So imagine this: if due to inconsistencies in your data or due to uh, unsurety, you might end up having lot of volume or lot of velocity. How can it be? How can veracity leads to larger volumes of data? Imagine that there were few sources, there were three different data vendors. One data vendor gave you data of temperatures. So these all the data vendors are giving you temperature data of a particular country. All right. Now, first you got data from all these data vendors, and then you would start churning and you would try to figure out which data is good and which data is useless and which data is duplicate of each other. But to do so, you will have to process the existing sets of data, and in the on the way of processing you might be generating further copies of the same data. So you might end up having 10 times of data what you had started with. So your temperature data could be say 1 GB, but because of multiple data, because we are not sure which data is right, which data is wrong, should we delete intermediate data, should we keep it? Because of this doubtfulness, this confusion, you end up having huge volumes of data, and hence the veracity can lead to the high volumes of data. And effectively, veracity is another reason why we have sometimes the big data problems. All right, makes sense? Any questions here? No questions? All right. Feel free to ask as many questions as possible. The sole purpose of these sessions is the sole purpose of these sessions is to promote questions, promote a lot of discussion. So please feel free to ask. All right. And do not wait for me to finish. Just you can keep answer ask your question as quick as possible, and then I'll reply to your question as soon as I finish explaining a topic. Great. Now next thing is, how many bytes are there in a petabyte? What do you think that how many bytes would be there in a petabyte? The number sounds small, the petabyte sounds small, but it is a big number. Yeah, anyone? So, yeah, how big is petabyte? That is my question to all of you. Are you able to hear me? Yes, Amit, you have a question. You're raising a hand. Okay. So Arvind says it's 10 to the power 15, 15 bytes. Good, good. Naveen says 1000 terabytes. That's also correct. And Jyotsna says 1000 terabytes. All right. All right. Anybody else? Yeah. So so the number of bytes are in order of 10 to the power 15. Instead of 1000 multiplier, it is 1024. All right. This table will help you remembering this. So starting with kilo, kilo is 1024 bytes, mega is 1024 kilo, and so on. All right. The other important part to understand is 1 byte here means 8 bits, and 8 bits can store 256 states. Okay. So basically, 1 byte is a pretty big storage. All right. And a petabyte is 10 to the power 15 bytes. Okay. So we will discuss more about this number, and to check the understanding of yours with respect to the big data, I have one more question to ask. So we talked about what is big data. Okay. So Shabri says it shows muted for me. So okay. So Sabrish, The every all the audience are muted. Only I would be talking. And if you have any questions, feel free to ask by the way of QA window. So, all right. Yeah, correct. That is correct, Manoj. It is around 1,000 terabytes. That's correct. So my next question is, okay, all right. And yeah, I am Sandeep Giri. Anjana is the one who started the session. Okay. All right. So my question to you is 1 petabyte really big data? Anyone? Srinivas says, yes, I think a petabyte is big data. Okay. Jyotsna says, no, more than that is considered petabyte data. Okay. So let me go back to the definition of our big data again. Big data, in if I have to answer you in 3 words, it would be any data that needs distributed computing. So distributed computing is the keyword. In a single sentence, big data means distributed computing. Now, and we will stick to this definition. The whole course, everything has been staged around the concept of distributed computing and the big data. So, question is, to handle 1 petabyte of data, do you require distributed computing, or or single computer will be sufficient? Would you require multiple computers to handle 1 petabyte of data, or one computer will be sufficient? Anyone? Anand says yes, it's big data. If we are processing it in real time, it's big data. Yeah. Naveen says Boeing generates 240 TBs of data. Yeah, correct. Correct. So Puneet says that yes, it might be depending on the scenario. Okay, okay. Anand says yes, it requires multiple systems to handle 1 petabyte data. And okay, so my question is, whenever you are faced with the challenge like storing 1 petabyte data, will you use multiple computers, or a single computer will be sufficient? All right. So the least you could do with the data is store it, and whenever needed, you give the you give back the data. As well, when you're storing it, you store it reliably. Reliably in the sense, in case there is a problem in the hardware, your data is not lost. All right, and that is why 1 petabyte of data is considered big data. So yes, most of the existing single systems cannot handle it. You would require a distributed architecture to solve the to handle 1 petabyte data. So most of you are correct. All right. So this is the standard graph, a little old now, but there is no other data being available. So this graph essentially shows you the analog storage and digital storage growth path. Okay, at what rate digital storage has grown, and at what rate analog storage has grown. Okay, over period of time since 1986 to 2007. The paper film, the audio tape, and vinyl, they all are considered analog storage, while the digital storage is in the form of hard disk, computer servers, CDs, portable disks, flash drives, and all of that. Okay, even a floppy is considered digital storage. So the most important part you need to understand in this chart is that after 2002, after year 2002, there was a sudden explosion of digital storage, while analog storage kept on shrinking. The digital storage kept on increasing day by day. The digital storage and the analog storage is also paper like books. Okay, so comparatively, and over a period of time, the digital storage had expanded by exponential growth. All right, as you can see this graph, this this area, the I think this is the gray color. It has grown really high. And why did it happen? The two simple answers. First is hardware, second is connectivity. While on one end mobile phone became so popular, or the hardware became, the devices became cheaper, faster and smaller day by day, and the connectivity, the various kinds of the networking solutions became very popular. You got Wi-Fi, you got 3G, you got broadband, you got various kinds of really fast internet solution. And because of that, as of today, the because of that, today we have humongous storage of data. The smartphones generate the data, or the devices generates a lot of data. Devices generate a lot of data. Your smartphone, for example, has camera. You keep on clicking pictures, you keep on sending messages. At the same time, it's synchronizing various applications and getting the data, right? Smartphones aid in generating the data, or devices aid in the generation of data, and connectivity multiplies it. How does connectivity multiplies it? For example, this session itself, I'm recording this session. The total volume that is going to accumulate at the end of session would be hardly 1 GB, and but the data that get transferred will be hundreds of GBs, depending on the number of, say, in this session there are assume that there are 50 people in this session. Now, if we if I'm transmitting this data continuously, because this video is being streamed to all of you, right? That means the same 1 GB is becoming 50 GB. So network does multiply the data. Okay. So connectivity, or the network, can be looked at two ways. One is Internet of Things, meaning things are connected to each other and things are communicating to each other. Second is the people connectivity, which is social network. People are now connected via social networks, so they communicate and they share the data over these networks. All right. Any questions here? Okay. So feel free to ask questions, even if you think that your question may be offset. Feel free to ask. Okay. There are high chances that the question you're going to ask, somebody also has that question in the mind and he's not answering. So your question might be very helpful to other people as well. All right. So don't hesitate. Keep on asking. It's up to me to decide to be able to answer the question. Okay. If I'm not able to answer, I'll tell you straight away. Okay. Now, next is this is something interesting where we talked about few things. We talked about what is big data, why big data is significant now, and why did it grow that way. Now question is the data has grown, but but why is it a challenge? Why is it a challenge to handle big data? Why do we talk about other models of computing? So the answer is in this slide. So when we talk about solving a problem using computing, in terms of computing resources, we require these four things: CPU, RAM, hard disk, and network. So when we talk about RAM, we talk about the speed at which you can retrieve the data from RAM and the size, how much how much RAM do you have. So CPU, which is basically going through various instructions, and based on the instructions, it takes various decisions. All right, and it stores reads right from the RAM, and the RAM has got really fast access time as compared to the disk. All right. Now, while the criteria for disk is the how much data can you store in it and how fast can you access. And interestingly, the rate at which you can access the data from disk is the bottleneck. The size of the disk is not a bottleneck generally. Okay, we can store 1 petabyte of data on maybe one computer by attaching too many hardwares to it, but accessing the data will become such a big hassle. At least you can store 20 terabytes of data on using one motherboard or one computer, but the read speed of the disk is something which will bother you. Fourth is network. Okay, so network would become important when you have to access data from somewhere else and process it. Okay, now if you look at the common flow of an application, they will be shifting the load from one of these resources to another resources over the journey of the application lifespan. For example, the say you launch the website today and it is slow because hard disk IO is slow. So what would you do is you will cache it. You'll cache it in the memory. That means you will move data from disk, that is point number 3, to point number 2, right? And in case your disk is not able to accommodate data, you will move to another disk in the network. And that's when the network will start becoming the bottleneck. Okay. So if you remember in our usual J2EE application, our application gets the data from SQL server or somewhere from the remote. And if your network is slow, the overall computing is going to be deeply impacted. So network is always the unsung part of the computing machine. Okay. All right. So this way, when you are dealing with big data, at least one of these components will become such a bottleneck that you cannot solve your problem using a single computer. Either your CPU, RAM, if disk or network, either of them will become the bottleneck. If your problem is complex in terms of the kind of algorithm are you using is basically consuming a lot of CPU, then CPU would become bottleneck, which means if the data is complex, generally the CPU becomes the bottleneck first. But in real life, it is the RAM that becomes the bottleneck in almost any any server computing infrastructure, the RAM is the one gets which becomes the bottleneck. For example, if you take the case of Wikipedia, it was the RAM that became the bottleneck. All right. So it also means that when you buy another computer, you get all these components with it. But in case you just remove one CPU and buy a faster CPU for the twice the size of the whole computer, twice the cost of the whole computer, then you are only getting CPU and you may not be solving the problem because CPU may not be the bottleneck. If you do an average of all the CPU, uh, free CPU on a network, you will realize that hardly 5% of the CPU is actually engaged over a period of time in a server computing infrastructure. All right. So Anand's question is zettabyte the max unit of big data now? So yes, as per the words, that's the word we have, but we can always call a million zettabytes. All right. All right. So yeah, if you try to do the computing, you will realize that we can actually do a lot of, you know, mixing matching. But right now, none of the companies are having data beyond zettabytes to process it. So Puneet is saying, so when we are talking about large or big data in petabytes, accordingly the RAM size also should be increased. Correct, correct. So yes, so generally when we are dealing with data, so some of your data would be in the disk, the RAM would be generally smaller in size. I have hardly seen 180 GB RAM so far in my career. So, and most of the data is beyond 180 GB or 200 GB. So, generally, you do not load everything into the RAM because RAM is a scarce resource. Okay, RAM is a scarce resource. So, most of your data lies in the disk or the network. RAM contains only the data which we want to process and we want to keep it at hand. All right. These are the few example big data customers. I'll talk about web and e-commerce because that's where I have worked most. So, recommendation engines, improving search quality. I'll talk about recommendation engine later. Let me explain to you what do we mean by search quality. So when we are building, everybody is building their own search engine internally, either using external tools or internal tools. Howsoever, all right. Now here, if you look at it, the search quality might mean a lot. If you try to build a search engine, you would realize that it requires a lot of things as compared to what we had imagined. Even if your data is small, even if you have not much of a data to churn, still the search quality will force you to start handling big data. Let's take a case. In our case in tbits, which was a document management system for an organization, the data was hardly 200 300 gbs, the kind of data we were handling. But when it came to search quality, we realized that the people's expectations have gone up. People expect search like Google and Gmail. So when people are looking for a word, when they type some word, it should autocomplete. Okay. And in case they are looking for a word, we should also be able to give them these suggestions, the alternative suggestions, the spelling mistakes, the other solutions. Okay. So for solving these kind of problems, you need to prepare various kinds of dictionaries, and so that you can help the user correct their typing mistakes, and also suggest the alternatives. Okay, you might have to cluster your data that these terms, people who searched for this also searched for that. So the search quality becomes really, really important. Okay, so even for handling a smaller data, even for providing the search on a smaller data, you might end up becoming the big data problem. Third is the sentiment analysis. We'll show you a few more details about sentiment analysis. Next is A/B testing. How many of you are aware about A/B testing? Nobody? No idea. Okay. All right. So A/B testing is a very interesting idea, and it's actually the most useful thing. So at Amazon, we have an A/B testing platform. What do we do with it? So whenever we are making a change in the website, instead of making the change in the to all the users, what we do is we ship that change only to few users. Okay, only to few users, and then see the feedback. If it is performing good, we increase the number of users which who will see this particular feature, the new feature, and then we measure, we compare the two, before the change and after the change. Both the websites are running in parallel, A and B. Okay, and effectively we will be able to concretely say whether a feature is good or bad based on the user's response. So this is called A/B testing. So at Amazon we do it very extensively. We do it very, very, very extensively. On Amazon's website there are thousands of different web pages that are running concurrently. Okay? Each feature, for example, buy now button, have got various variant, and all these variants are being run parallelly in order to figure out what is best by comparing the sales happen due to different colors. Correct. All right. So A/B testing is this. Now, so when you deal with the A/B testing, you will realize that if you have lots of users and you have to do a lot of churning, you have to figure out the percentages. You have to route the traffic. All of that would require a big data solution, a distributed architecture. The ad targeting, what does it mean by ad targeting? For a company like Google or InMobi, where their role is becoming the ad brokers. So on one end, you have people who are playing games, who are browsing web, who are listening to music, and those are your real estate for showing the ads. So you show the ads to them, and on other end you have inventories. Inventories as in there are various companies who have put created ads on your website. So on one end you have millions of users, on another end you have thousands of ad to be displayed. Okay, so millions of slot and thousands of ads to be displayed. How do you display the which ad goes where? Okay, so that matching requires a lot of processing. There could be hundreds of criterias. Some users might be playing a game which says that which tells about its genre and the country and the various parameters. And on another end, you have these ads which themselves tell that do not display my ad on these apps, or do not display these ads in India or in US. If it's related to medicine, don't display these ads in US. Okay, so so you have on one side you have inventory of ads, on another side you have this humongous real estate, and you have to figure out what is the best way, what is the best possible ad you can provide to a consumer so that the probability of clicking the ad becomes really high. So that is called ad targeting. Ad targeting is again a big data problem. Now, in case of telecommunications, you could prevent the customer churn. You could help network performance optimization. How can you prevent customer churn, prevent customer leaving you? Is when the customer leaves you, note down what were the 10, you look up what were the 20 things done before the consumer left your services. Okay, and those 20 things could be: what were the call logs, how long did the call last, for how long in 1 month, past 1 month, what has been the access pattern. Okay, for how much time was he out of coverage area. And that would give you real insight into why are your consumers leaving you, why are customers just leaving you. So those kind of insights are required. Next is network performance optimization. Okay, so based on the traffic, based on the usage pattern in the city, the various telecommunication companies do a lot of optimization because of the user flow. They also do calling record data analysis at various levels. And to handle any of these problems, given given the number of peoples, given the humongous data, these all problems become the big data problems. Okay. Next is analyzing network to predict failures. This is very much possible because every every network failure starts somewhere, and you can always predict that these are the signs of a network failure. Okay, so Puneet is saying, can you once again explain about A/B testing? Basically, you keep two versions of your website. One is old and other is new. Okay, and new version you only show it to few users, not all the users. Okay, so this mechanism, this philosophy is called A/B testing. There are various A/B testing tools available in public for free. All right. So before launching a new feature, new website, you generally test it using A/B testing. And first, you show the new feature to only 0.1% of the users, random sample. And after that, you keep on increasing this percentage. So I'm not sure if it is, Sabrish is saying any full form is here. His guess was alpha slash beta testing. So I'm not able to recollect the full form of A/B testing right now. Okay, okay. Generally, we say that there is A and there is B, and these are two variants of our experiment. And the A/B testings have been far before the technology came into play. Okay, so A/B testing comes from the background of statistics. And in A/B testing, there is whenever there is a drug that is going to be shaped, you need to do A/B testing of drug. You give drug to some people, and you give uh, you give the old drug to some people, and then you compare the results. If there are no side effects, there is no, the impact is similar or better, then you go ahead with the actual drug. So you do, there are standard mechanisms in case of drug discovery, in case of a drug manufacturing. The A B testing is utilized there also. I mean, that's where the A B testing came again. Okay. Jyotsna's point is, can you explain calling record, calling data analysis? So based on calling data, based on who is calling who, and on what time, what is the pattern of people calling, you can do a lot of interesting things. Okay. You can give the better offers to people. You can provide a better service to them. Okay. So calling data analysis, calling data record analysis helps you solve a lot of problems. Yeah. Okay. So Anand's question is, will there be any techniques to do sentiment analysis? Suppose I want to retrieve top 5 positive real-time tweets regarding Sachin. How do I go about this situation? Okay. So yes. So when I'll explain to you the sentiment analysis and then would give you a quick idea, and then you will be able to understand it. All right? That was Anand's question. Now, let's talk about recommendations. Recommendations has been going on even before the internet came into play, or even before we learned to use internet. As a child in the school, we always used to ask our friends, "Do you like this movie? Do you like this movie? Do you like this movie?" And then, based on their feedback, we try to figure out which friend is very close to the choice of mine, and then we take their recommendation. So most of the recommendation systems actually work that way. So first form of recommendation is that customers who bought this also bought this. So here Amazon doesn't know about your preference. Amazon doesn't know about your preference. Okay. So, but still, since you are looking at this product, so Amazon is able to tell you clearly that people who bought this also bought that. This is the very simplest form of recommendation. And trust me, most of the sales of Amazon happen because of recommendations. When they send the newsletter with the recommendations, most of sales happen because of that. And the more personalized recommendation you have, the better it gets. There could be another kind of recommendation where it's partly hand curated and partly it is composed from the data. That kind of thing is wear it with, meaning you try to complete the set. People, do you figure out when people buy this kind of dress, they buy this kind of other you know, the accessories. Now, a more personalized recommendation example would be the Netflix example. Netflix knows that you have watched these movies and you have also provided your feedback on these movies. Based on that, it can give you that we think you will like these movies. Okay? We think that you will like these movies. So, based on your past choice, similar is the case with IMDb. And to handle these kind of data, because if you understand correctly, the bigger the data gets, the better would be the recommendation, right? The bigger is the data, the better would be recommended. There will be more people who are similar to each other, more similar than the the in the small data. Okay, therefore a recommendation engine is the one which make more sense to do on the big data right away. All right. Recommendation engine is also called collaborative filtering and is basically the most popular use case of big data in real world. So these are recommendations. So if you guys know that a few years ago Netflix ran a contest $1 million prize to build the recommendation engine algorithm. And interestingly, as of now, all of those algorithms are freely available as part of various packages. Okay. Now, this diagram shows that how do you generally generate the recommendation. So here it's very irrespective of what kind of movie it is, who is the user, we are generating the recommendations using a component called Mahat. Okay, we will this will be part of one exercise in our class, but here we'll just show you very quickly that what exactly how exactly people do recommendations. Okay, so first this is the most rudimentary one where you have got user ID, movie ID, and how much this user rated this particular movie. Okay, so that is the input to Mahat, and after Mahat gets all of this input, it will give that this user will like this movie and this much. And how did Mahat do it? Any guesses? How did the recommendation by Mahat got generated? Yeah. So basically, it tries to correlate which users are similar to each other and then start cross recommending them. Correct. That's correct. Sabri says that it is based on user ID and movie ID. That's correct. So out of this data, all you need to do is prepare this three-column Excel sheet or three column comma separated file and feed it to Mahat, and Mahat will give you the Mahat is a command. You can use that Mahat to give you the recommendation. If you look at it, using Mahat would be very simple, but preparing this three-column CSV file will take a lot of time, and ratings should be somewhere between 0 to 5. All right. So that's where the role of a big data developer comes into play. That given a given some amount of data, they need to prepare this kind of CSV or whatever format you want for feeding into algorithms. Okay, so we'll go into this full example in session numbers 8. And a sentiment analysis, these are the examples of big data problems. A sentiment analysis is understanding the sentiment of the public towards your towards your brand, towards your promotion, towards any event. What has been how did the sentiment change? So you can do sentiment analysis on various sources of data, but since Twitter's data is most popularly available, you generally do that using Twitter's data. Now, how do you find out whether one particular tweet is positive or negative? So this is generally done based on the dictionary or using a natural language parsing system. There are multiple ways to get it done, but the most rudimentary form is You take a dictionary, there are dictionaries available which tell you that whether a word is negative, positive, or neutral. So those dictionaries you can utilize for sentiment analysis. All right. Now coming to question Anand's question. So to do the sentiment analysis, as I told you, that you will utilize the data downloaded from sources like Twitter. So Twitter's API provides you the data to download from their website. There are many tools. There are Python script, if you try to search, which will basically given the API key and basically login password and tag you are looking for, these tools will give you the data, will download the data for you. Or you can use these tools to push the data directly into Hadoop. Okay, make sense to you? So sentiment analysis is a very interesting problem which is being solved using various big data tools in real time. Politicians are using it to figure out whether their campaign is working. Various advertisers are using it for various kinds of purposes. So sentiment analysis gives you the real feedback of your activities. All right. The other example of big data customers is government and healthcare and life sciences. Government can utilize big data for fraud detection, and in general, the benefit of bigger data over normal data is normal data might be biased. Small data might get biased. Okay. While the big data will not get biased because it is based on, because it has got a huge variance and it encompasses more situations than the smaller data. Let me ask you this. There are two hospitals, one of in the same city. One of them one of them has got the, as per one of the hospital's statistics, the newborns, the female newborns are 40%. So there's a hospital A says that female newborns are 40% and male newborns are 60%, while there's another hospital which says that female newborns are 49% and female uh, and male newborns are 51%, right? So there's A which says 40/60, there's B which says 49/51. So which one do you think has got more data? Which one do you think has got more patient histories as compared to the other one? A who says 40/60, B which says 49/51. So do you think it is A or B who had more customers as compared to the other one? Yeah. So which one do you think? So there are two hospitals, A and B. A says that there is a 40/60 ratio between female and male newborns. B says B hospitals the statistics say that the ratio of female to male is 49/51. Which one, A or B, has more customers or more patients or more newborns? Hospital B. Excellent, Puneet. Thank you. Thank you, Jyotsna. Great. Great, Anand. So, yes. So, it's the hospital B. Why? Because the bigger data it is, the better it would be, right? How many times we hear people saying that uh, that based on our personal experience, the people who have no people, based on people's small data, they try to deduce a lot of wrong conclusions, right? So So the bigger the data, the better are the conclusions. The more correct are the conclusions. For example, you will hear a lot of people saying that the people who I have seen in my life, most of them who got cancer never smoked. But in reality, when people did a bigger strategy, bigger study over the whole geographies, then they realize that smoking definitely has something to do with cancer. Okay, so it's a data game, all right. And this whole philosophy is also called law of large numbers. Okay, law of large numbers, as meaning as you keep on throwing a dice more and more times, the total number of head and tails will become equal. As you keep on throwing the coin again and again, uh, millions of times, the chances are, if the coin is unbiased, now total number of heads and tails will be equal. But if you just throw it twice, there are chances that either there are more than 50%. There are situations, there could be aberrations, right? So that is the reason why big data becomes a very important aspect in anybody's strategy. So at various places, even for a company like ours, no big data, we do analyze a lot of data from our users. For example, we before we build a website, we went through our user base, which browser do they use and all. And now in the new version, we will be incorporating, we'll be considering all those browsers which matter to us. Okay, so and this is a standard strategy at everywhere. People churn their local data, local Apache, churn their own Apache logs to figure out how is figure out the user's behavior. So Puneet's question is, so does probability also comes into picture here? So whenever you are working on any data science problem, there are very high chances that you will go through probability multiple times. Okay, so if you are once you master the art of big data development, you might want to move to data sciences, where you will do a lot of statistics and understanding of doing machine learning on top of data. Okay, yeah. So probability does matter a lot when it comes to any of this. For example, in movies, when we compute similarities, so that's where we utilize the probability distribution. All right. Now, these are the installations of Hadoop, not really big data customers, but Hadoop customers, you can say. The bigger the font, the more number of instances they have. So Yahoo has got maximum number of instances, and there would be somewhere in Mobi also. Amazon may not be there because at that time Amazon had not accepted it. Why can't I see? There must be in Mobi somewhere in this chart. Yeah, here it is. Just above LinkedIn. That's correct. Thank you. Thank you, Puneet and Anand. Yeah. All right. So there are many companies who have been using Hadoop and big data. So these are common 11 myths which I've gathered, and these common myths are: first one is big data always means data above or in range of terabytes. Okay. So do you think it's a myth? Yeah. Do you think the point number one is myth? No? All right. Yes. So, as we talked about variety, and we said that even if data is very small, you might end up using distributed computing just to solve the problem because the problem might be complex. Okay. Even if data is small, if based on complexity or variety of the data, you might have to utilize big data solution. Right. Big data is always about social media. It does not apply to me. It does not apply to me. So that's not true because it's not the only social media. There are many more use cases of big data. Okay. It's only the creativity of yours which should play the role. And for example, at InMovie, it is not a social media company. It's a usual company with lot of Apache logs. And we did a lot of predictions there. We'll replace EDW, which is Enterprise Data Warehousing. Okay. So it will not replace. There's a common myth going around that old databases are going to go away because of this new databases. Answer is no. EDW will remain as is. Okay. Why? Because purpose of EDW is to have very structured and relational data. None of the databases can and will provide, none of the big data databases can and will provide a consistency like relational databases. Therefore, EDWs are not going anywhere. The data that requires humongous consistency and transactions that will remain in EDW. It is just a buzzword, no practical application. It's no longer a buzzword. Okay. So everybody has already, it's not like, unlike other technologies, this is a real technology in the sense that companies are already using it and they are getting benefited every day. Every second day, a new startup is coming up with a big data idea and they are able to solve really, really complex problems. Is a new concept? The answer is no. As I was talking to you about in 2002, we were doing the similar stuff what other people are doing now when it comes to big data. And we were doing at D. So it has been going on for quite long. It's just that it was not commoditized till date. Thanks to Hadoop and thanks to few players to make it commoditized and make it available to everybody rather than only few people. Will be the future. It is not, will not be the future, it is the present. Is expensive? No, big data is not expensive. Big data is big data solutions are fairly cheap. All the solutions are open source. All the tools, whatever you see, they can be installed by anybody. The documentation is available everywhere. It's only the lack of people which is making it expensive. All right. Is only for data scientists or is magic? The answer is it's no longer a magic, and it was for data scientists, but all the things which data scientists had to do, they have made it available as a library. We have enough hardware, we don't need it anymore. So we are not, a big data solution does not mean hardware. Okay, it's just software stack which matters. And most of the solutions are built in order that they can run on any kind of hardware. We will build it when we need it. That is another myth. The problem is people who are living their normal life, who have not tasted big data, they will not realize that there is any need. Okay, and effectively they'll be left behind. By the time they wake up, they will realize that they don't have much of a customer data, uh, and hence they'll not be able to give insights. Okay, so that is another problem. So that's a vicious cycle. A lot of companies anyway go through it. 11 is big data is not only about Hadoop. There are multiple solutions. Now coming to the question, what is the difference between Hadoop and NoSQL DB? That is Anand's question. So Hadoop is the full ecosystem of components, and also has one NoSQL DB called HBase. Okay. Hadoop has one file system, one compute engine layer, and on top of all of this, it has import and export tools. And there is one NoSQL, there is a one analytics engine. So all of this is a part of Hadoop. Okay. So now basically NoSQL DB is just a subset of Hadoop. Lack of people, do you mean lack of resources? Yes. Lack of people as in lack of trained people. Okay. Puneet is saying that was Puneet's question. Okay. And yeah, lack of, yeah. So his full question is, do you mean lack of resources with proper expertise in big data? Yes, that's correct. So yeah, any other questions here? No. All right. So these are the few numbers which I computed last year from Naukri.com and Indeed.com, and probably you should also see that. You should also try that. Okay. Go through Naukri.com, Indeed.com, and try to analyze the kind of jobs you will be looking for, and similar kind of job, similar kind of experience, the salary difference between the big data technologies and non-big data technology, the difference is humongous. As you can see that the number of jobs in higher salary ranges are there in case of big data, while lower salary ranges, this one is, if you see the bars here say, okay, bars here say the red one, the below, the blue one is Java and red one is big data. So the salary jobs 0 to 3, the sorry, J- so Java is red one, blue is Hadoop. So from 0 to 3 bracket, there are more jobs in Java than Hadoop. But in the bracket, say 6 to 10 lakhs or higher, the ratio of the number of jobs in Hadoop is far higher than Java. Okay, so which means the salaries, there's a humongous difference between the salaries of two technology guys. And learning wise, it does not take much time to actually get into the Hadoop ecosystem. So it's a good opportunity for a lot of us to learn this new technology and do a career switch. Along with that, as a quick experiment, you should see that by adding few big data keywords to your profile, does it really increase the traffic of people coming to your profile? Okay. So you should do that experiment and try to figure out that does it really make sense for going ahead with the big data domain. Now Anand's question is, if I can build my web app on MongoDB, can I use Hadoop with MongoDB? Can it be plugged in? Yes, it can be plugged in. If you see one of my videos where I have integrated MongoDB and Hadoop using Mongo Hadoop, then you will realize that that is fairly possible. All right. You can try using Mongo Hadoop, Mongohadoop. That's a GitHub project, and also you go through my videos. So Puneet says that he's into software testing, and I will wait for his question. How feasible it is to switch over to Hadoop? It is very much feasible, and I would recommend that you should go for Hadoop development course. because even if you are in testing, you need to know a bit of programming, okay, and you need to know a bit of understanding of the whole engineering stack, okay, because I believe that a testing engineer should be involved from the beginning in a project, and effectively a testing engineer need to know everything a normal developer need to know, okay. So generally at places like Amazon we do not generally differentiate between SDE and SDET, all right, and SDET are mostly into development. They are able to test things more thoroughly, okay. So it is fairly possible to to shift into Hadoop even if you are from testing background, right? That's very much possible. And that's what the most of the newer technologies play the role. The role of newer technology is generally to help people switch their uh, okay, switch their career. Because when a new technology comes along, what happens is everybody is new in that area, and effectively everybody gets the equal opportunity. Nobody can say that, oh, I have these many years of experience and hence I am more qualified. No, because there's a role being played by any new technology in case of an IT era. So Sabri's question is, I am overall 7.5 years in Java and J2E, little development, support and maintenance. What will be the employer's expectation from big data, hands-on expertise? So yes, as of today, the good part is most of the good companies are actually looking for people who are more hands-on. Okay, so that is why we also prepared a course which forces people to be hands-on. This Hadoop course which we are talking about, it will make you do things. It will make you work along rather than being just the audience. Okay, and so this will help you in. So expectation will be there. Trust me, expectation from employers would be there as of today that you should be hands-on. The reason being, in a company there will be only maybe 2 to 3 people into big data, and when you have 2 to 3 people only in a team, that means you might have to do everything by yourself. Okay, that gives you a great opportunity, as well as that gives you um, great exposure to various kinds of technology stack. So Puneet's question is, so developing, I mean, programming skills are must, you mean? So programming skills, as in you should know the basic construct of any tool. You should know how to write a for loop or while loop. You should be aware of the programming. It doesn't mean that you should be thorough with all the object orientedness and thorough with any of this. So when I say developing, you should be aware of these programming constructs, because the programming constructs are same all across languages, and when you go into any development area you will be basically experimenting with new tools, but programming constructs will remain. All right. Now Rishu's question is, do you see role of big data in banking software products? Definitely. So in banking, big data will not replace the heavily transactional systems, such as in real time, the real time banking solution, real time account management, or real time accounting will not be something where big data would play a role. But in other roles, banking, insurance, the whole BFSI industry is actually taking a humongous benefits by doing a various kinds of analysis on top of users' behavior. Okay, they have already started doing it, and they are utilizing it for various other purposes. The old statement, the previous year's statement, which is no longer required in production, is being managed using these tools. All of the data which you do not require in transactional has been moved to Hadoop and big data. And if it's not moved, they are in the process of moving. I met Goldman Sachs, I met Morgan Stanley, I met few more companies who have started on a strategy level huge investment into the big data technologies. Okay, makes sense to you, Rishu? Sagar's question is, I am a fresher. Is it possible to work on Hadoop? Okay, so see, whenever this Hadoop development comes into play, our expectation is that you should know basic constructs of any programming, and basics of SQL, and basics of Unix command line. So that's a simple expectation from everybody who is coming with the background of Hadoop or is coming to learn Hadoop. Right? So if you have those three areas clear, these three aspects clear, then you should go ahead, and this will actually help you in the career a lot. So Puneet's question is, and what would be the programming language that one should know? So programming language is very, very subjective. I would say whatever you have been exposed to more, just use that one. And if you are okay with, say, Java basic construct, you will be fairly confident quickly if you are given any other language to work on. Okay, so this is a general pattern. The first language takes a lot of time. First basic construct takes a lot of time to learn, but rest of the languages, the learning new kind of technology or language becomes far easier once you know the basic construct of any programming language, any one. Okay. But if you are just starting and you're doing it for personal reasons, start with Python. That will keep your interest going. And uh, at later point of time, if it's a Java problem, then also you can solve it quickly. So Vikas's question is, hi Giri, I'm MCA graduate 2006 and I have a 5.2 years experience. I have 3 years industry gap. Should I join big data course? How employers will treat me? Will they consider me after 3 years? That's a very good question, and probably this applies to a lot of people. There are many kind of people who take gap because of personal reason, because of family reasons, and it's very, very natural. And I have met lots of people in recent time. After I started all of this, I realized that the whole course actually benefits lot of people who have taken a gap, who are new to industry, who have taken a gap, who are switching from one industry to another. All of all of these people get benefited because of a new technology introduction, because a new technology introduction such as big data brings everybody onto the same platform. Okay, and the moment you know something, you have a skill which is rare in industry and is in high demand, then y- then you will have far more chances of getting picked up. Okay, so definitely whenever you have taken a break or have done something, you pick up a technology which is newer and which is in higher in demand. And out of all of this, if I compare, say, Node.js, MongoDB, and Hadoop, the Hadoop has got the highest demand in market as of today. I'm telling you based on my numbers, my statistics. Right. So I hope that answers your question, Vikas. So of course, everybody. What I'm seeing right now, say we have knowledge partners, say ITC Infotech, for example, or I have a few knowledge partners from like Dell and now IBM also. Their problem is they are not finding enough good guys into big data. So if you have knowledge about it, it will become easy, and your gap or your current industry will be overshadowed. All right. Big data handles transact only with present data in BSI. No. So I was when I was telling Sabrish's question is big data only handles present data. No, my point was that big data does not handle none of these big data solutions, starting with MongoDB, Cassandra, any of other database solutions which lie into big data domain. Most of these systems cannot give you the ability for transactions. Okay, they cannot give you that really reliable transactions. Therefore therefore you would not use big data solutions or NoSQLs for your problems where you need strong consistency or strong transactions, right? If you will not use big data solutions for those kind of problems, and therefore the transactions are generally required in current data. The past data, which is sort of archive, you don't require transactions there. So those data will be moved in BFSI industry. All of that data will be managed using big data in Hadoop. Along with that, the newer generation of problems like if a bank is doing a credit analysis, a history analysis of the users, they can very well do it on Hadoop. That will be far better. Okay. So that was a little bit about BFSI industry. Will PHP will PHP be applicable if I go for career in Hadoop or big data or machine learning? So most of these tools actually work either on Python, Java, or newer languages. So knowledge of PHP will be good in terms of the programming constructs, you're comfortable with the idea of computing, and so only in that sense it will help you. Okay. The other aspect is, say for example, we talked about recommendation engine. In recommendation engine, we generated recommendations, right? Now, to present these recommendations, you will have to transfer this data to your normal PHP web server MySQL and present it using PHP. So it does complete a role of visualizing data. So if you have prepared a really good statistics and you want to present it to the end user via your portal, then PHP skills will complement your big data skills. All right. Hope I am able to answer your question, Amit. Which DB is most preferable to store data and why? So that is Anand's question. So it all depends on the problem you are trying to solve. Okay. So his question is, out of all the NoSQLs we see so many, you have normal MySQL kind of databases. All right. You might have a normal relational database. You might have Redis. Redis is an in-memory database, and you have MongoDB, Cassandra. There are so many mm, databases. So it requires you figure out the strengths of these databases and when to use what. And that is why in session number 11 we go into the details of when to pick which database. All right. So generally, when you have to do a lot of memory computation, you go for things like Redis, and everything can be loaded into memory. Then you go for Redis. If you can't handle it in memory, then you cannot use things like Redis. And then if you require a if you want to store data in objects format, you go for MongoDB. If you want the data to be stored mostly like a relational tables, you go for HBase or Cassandra, and so on. So we can have this discussion maybe later. And all right. Naveen's question is, what about Hadoop, big data, and IoT? So yes, all of them will fall into place. When I was telling you about two parts, one was devices and other were connectivity, right? And when Connect talked about connectivity, there were two parts. One is device to device connectivity and people to people connectivity. Device to device connectivity means the IoT parts, okay, Internet of Things. So Internet of Things has evolved recently because of availability of so much of open source of hardware and a community development. Now because of that, there is a new wave by which people are able to build brilliant devices so cheaply, which can connect and do a lot of you can generate a lot of data. So generates the data IoT generates big data that is stored on Hadoop. Okay, that is how Hadoop, big data, and IoT are correlated. All right. So IoT generates big data that Hadoop handles it. Okay. So Vikas is saying after doing course, will employer consider it as experienced professionals? So I would not, say that part because we do not give any experience certificate. We just give you 2 years or 2 months of course. The course experience we give you for 2 months, and that experience basically does count for lots of people, but it's not something I would promise. All right, but it does matter to lots of employers. Next question from Srinivas is it possible to use graph database in big data tools? Of course, that is very much possible to use graph database in various big data tools. Okay. Now, Sabri's question is, we see lot of NoSQL, Cassandra, MongoDB, and more to come. In that case, the current design will be easily migratable within big databases. Yeah. So people have written various kinds of connectors which help them migrate from one design to another. So because nobody will have any other option than preparing tools for migration. All right. Now, Anand's question is the course in class or online? So our all the courses are all uh, online. There is no in class. We stopped in class because first, the performance of a student who attended our physical class was not great. So our online students performed really great. Therefore, we thought that we'll just keep it online. Second was availing the instructor in the local geography was impossible, and I mean the instructor which you can get locally are the people who have never worked in any big data technologies. Okay, so that is why we kept the whole model as online. All right, next is Shabri. Okay, Vikas's question is, what will be salary for my kind of profile? Your okay, your kind of profile was okay. So that's very subjective, very subjective. So you can map here. So I think the answer better can be given. Sorry, I by mistake deleted your question. Yeah. So that the answer can be well given by Naukri.com or Indeed.com. Okay. The course timing will be the one which is starting on this 18th of April, and will be in the evening from 8:30 to 11:30, and the one which is going to start on 25th April is going to be in the morning. All right. All right. So yeah. All right. So let's take a break for 10 minutes and we'll come back in 10 minutes. And the timing, let me correct the timing. We will come at, okay, we'll come back at 9:10. Till then, let's take a break and then start again. All right. Alright, so should we start now? Just one more second. Alright, so let's start now. So before starting, let me try to answer your questions. So Srinivas, you can basically, for signing up for the course, Srinivas's question is, what is the course timing? You can go to the website, and based on your geography, it will show you the correct timing here. Okay, so these are the two courses which are coming up. One on 18th April, other is on 25th April. Okay. The if you are visiting this website, it will show you the time in your own uh, time zone. Okay, so that will be the better way. Sabri's question is, which course are you talking about now? So this is a Hadoop development course, and this course basically takes you through the whole uh, around 13 products which lie under the umbrella of Hadoop and related. So all the materials is available online, and you can actually register, and whatever is the basic classes, those will be available under your my courses automatically. Poonam's question is, I have 7 months of experience in Java and 8 months experience in Python. Can you suggest which language will be more preferable to work on Hadoop? So both, I would say, both would be equally useful. And if you are customizing, doing a heavy customization of Hadoop, then it will be Java. And if you are utilizing the tools like streaming, then Python would be good. Along with that, you will have, along with that, Python can be used very well with Spark and real time. So both languages will be good enough. Okay, and you are lucky to have both the languages and experience in both. And Naveen's question is, what type of infrastructure required to set up own lab to learn, test, and practice, implement use case as project? So that is Naveen's question. So Naveen, do you one way of doing it is, we provide you the clean instructions on how to start using our cloud labs. Okay, we have set up cloud labs for all our candidates. They don't have to install anything. They have to just connect, and then that's it. But in case you want to set up your own, we provide you a virtual machine. We provide you a virtual machine which you can install and run. All right. So so i- in case you are planning to set up your own small cluster like ours, then it will be a little bigger exercise. It will not be, because our cluster runs on multiple computers. If you just want to install on your own machine, that will be good enough for most of the learning. Okay, that you can basically do using a virtual machine only. You download the virtual machine, right? Download the virtual machine of Hortonworks, run it using VirtualBox, and that should be good enough. The person who is preparing for data scientist, does it necessary for him to have the complete know of Hadoop ecosystem, or awareness only will be enough? So yeah, awareness should be enough. Okay. If you're preparing for sciences, you should have a good knowledge about a few things, such as you should have a good knowledge about MapReduce, and you should have a good knowledge about the Mahout, and you should have a good knowledge about The technology is like Hadoop streaming. And when you are dealing with data scientists, what else do you require? That should be good enough. If you are thorough with MapReduce and you are thorough with the uh, thorough with the Uzi and Uzi MapReduce, and that should be good enough for you. Yeah, yeah. It will be an online course, live course, as in the way today's session is happening. It will happen in the same way. Srinivas's question is, do you provide certificate? Yes, we do provide certificate, and our certificate can be, we provide you a permanent link for the certificate, and that can be displayed on LinkedIn. Will you provide job interviews at the end of training? Do you mean the mock interviews? For if you want, we can provide you. Otherwise, it's not part of our process. But if you, there are only few people who want that. So if you want, we can provide you a mock interview. So, actual company interview, we cannot guarantee you that. All we do is all our knowledge partners, such as Dell, ITC, L&T, L&T Infotech, ITC Infotech, Dell, and IBM, we basically connect you to them. They keep on sending us the vacancies. We just forward it to you, and it's up to you to connect with them and talk to them. Okay. Or once the course finishes, we take up your resume, and whenever these people are talking to us, we just give them your resume that here is the guy, and the rest is up to them. So that's the kind of thing we provide, but I would not promise any kind of job thing. All right. Now, Puneet's question is, deploying or installing Hadoop, is it something like Linux installation? So yeah, deploying and installing Hadoop is first. The biggest difference between any software and Hadoop is it runs on multiple computers simultaneously. So you'll have to install the software at multiple computers. Okay, and then you have to make them run. So once you understand the basics of Hadoop, you will have a better answer for this. Okay. Yes. Poonam's question is, will you provide hands-on assignment in cluster? Yes. So we will basically provide you the questions, you log into the cluster, you try to solve them, and then we can, review it. All right. So, okay. Any other questions before we resume our session? No questions. Good. So, all right. So we talked about big data, and in big data, these are the various big data solutions. You can say these are basically sort of answer to most of the big data problem. The most comprehensive out of it is probably Hadoop. And then there is Spark. Spark is only for computing. It doesn't have a storage or a database. Then there is Cassandra. Cassandra is only storage plus MapReduce, but it doesn't provide you exhaustive library of computations. And then there is Google Compute Engine. It's basically a hosted solution from Google. You basically upload your data to Google and then start running the queries on that data. So your um, ability is fairly limited by what Google provides you. Then there is MongoDB. MongoDB, similar to Cassandra, is able to store data, but nothing beyond that. All right. Now, what exactly is Hadoop? Hadoop is was created by a person called Dog Cutting, and along with Mike Caffarella, when they were when they were building their Nut search engine project, and it was based on a paper. three papers from Google: Google File System, Google MapReduce, and Google Bigtable. And Hadoop has been named after the toy elephant which dog cutting son was playing with. And the license is open source, meaning the Apache license, the one Hadoop uses is Apache. And how does it matter? So out of all the licenses, Apache license is the most liberal one. Whether you are working for an organization, with enterprise, profit, non-profit, and all of that, you can easily start using Apache license without having to worry about paying to anybody. Okay, you don't have to pay to anybody. Hortonworks charges because they provide support to everybody. All right. So Hadoop is fairly open source, and probably the reason why Hadoop is successful is because of this licensing. It's powerful and it's quite supported by various parties. There are parties like Cloudera, there is Hortonworks, there is Mapr, there are other parties as well. It's a framework to handle big data. It's for reliable, scalable, and distributed computing. Okay. The point number H is what basically means. So Hadoop started with these three components, based on these three components: one file system, other was a compute engine called MapReduce, and third one was HBase, which was based on Google Bigtable. So it started with these three components, but now there are many components which lie under the umbrella of Hadoop. Okay. So all of these components have a single philosophy, that they all need to be for reliable, scalable, and distributed computing. Reliable means if one computer goes down, still your work does not get hurt. Scalable means Scalable computing means in case you need more computers today, you can add it to the cluster and software should expand to it. Distributed means the work should be divided amongst computers. So all of the components that lie under the umbrella of Hadoop, they all follow these three principles. All right. And it's written in Java because it was supposed to run on all the machine. It does run on every kind of machines. As of today, it also runs on Windows with HD Insight. There is something called HD Insight from Microsoft. So that runs on Azure on Windows platform. Okay, which means Hadoop can actually run on every machine. And the reason is Java. Wherever Java can run, Hadoop can run. All right. So let me answer a few questions. So Amit's question is, can Hadoop cluster exist on different OS like Ubuntu, CentOS simultaneously? Yes, it can. And in given today's time, one node can be in Linux, other node can be in CentOS, Unix, or a third node could be in Windows. Theoretically, it is possible, but I have not personally tried this. All right. Now, Poonam's question is, will we get cluster images to do the assignment on our own? No, it's a shared resource, and all it has been mirrored on the idea of the way it actually happen in organizations. The way it happens in organization is there is a shared cluster on which Hadoop is running, and everybody will be putting their jobs onto this machine. Everybody will be using these machines for the execution of their work. So that is how it happens in organization, and Cloud Labs is also built exactly that way. Okay, because it is very important for each individual to feel that when they run something, it runs on multiple computers. And for example, there is one tool, there are many such example I can give you, where The users who are able to do things on a single computer, single virtual image, they are not able to solve the problem on cluster. And because they get into still the psychology that it's a local thing. And there's a difference in the paradigm between local and distributed. And that is why we have kept it absolutely distributed. And hence, we cannot provide you the image of four clusters uh, because for that you'll have to set up four computers separately. Puneet's question is, do you even teach others like MongoDB? No, not right now, but we have the course ready. We have self-paced course running for MongoDB, but we are not right now actively teaching in MongoDB. No. So, just a second. So, yeah. So, Sabri's question is, will the course cover all the products in the slide? Yes. The course will cover all the products on this slide plus one more component called Zookeeper. Okay. And let me have a look at it. Yeah. So we will cover all of these. We'll cover HDFS, we'll cover Yarn, MapReduce, HBase, Spark, Hive, Pig, Moz, Uji, and Flume, Scoop, and we will also cover Zookeeper. All right. All right. Naveen's question is: some data in Windows, other in Android, and rest in Linux. Could Hadoop connect special data for analytics? Yes, it does. But you'll have to install Hadoop client, Hadoop everywhere. All right. What are Flume and Scoop? Flume and Scoop is for data importing and exporting. That is Robin's question. In Hadoop, computing is moved to data node and data is processed on data node RAM. That is Jayaprakash Bharati's question point. Similarly, in Spark 2, why is Spark so fast? So Spark tries to exploit the memory, and that is why it is fast. Also, the intention from bottom up while designing Spark has been that it should be done real time. Okay, make sense to you? So we will go into those details exactly why Spark is fast. Right. So let's start with our main components. So today we are going to discuss a bit about HDFS. We only have 30 minutes left, but rest of the things we can cover in the session too, no issues. All right. Now, my question to you before I start is, if you have 100 terabyte data, how would you store it? Or let me rephrase the question. You live in a hostel or you live in an apartment, and all of you, your friends and everybody, your neighbors, they all said that let's build a central movie storage. A central movie storage where we all can store our movies and we can watch from there. And this storage, on the back of the envelope calculation, you figured out that it has to be at least 100 terabyte. Now, my question to you is, how would you build such a storage? What will be your assumptions? How will you design it? What exactly will you do? Anand says LAN. Sabri says cloud. Okay. No. So here we are trying to build a cloud. All right. Here it's local. If we put our movies in the cloud, then downloading them will take a lot of time. So my question is, how would you build 100 terabyte storage? Naveen says cloud into local caching. Split. Jyotsna says split and store. Good. To make it distributed among among computers. That is Sabrish's point is to make it distributed among computers who are already connected with Hadoop or big data. So yeah. So without Hadoop or big data, how do you generally build it? So what am I trying to do is I'm trying to establish that if we build in a traditional manner, then these are the challenges. So yeah. Poonam's point is can be divided and stored at different locations. Good. Okay. And then hard disk. Okay. Good. All right. Any other? All right. Now, this is the general approach we used to do. And probably you guys also have answered it the same way. So, what you do is you take these, you prepare these computers with 100 terabyte of space, meaning you bought 101 terabyte hard disks and installed these hard disks in 100 computers. Now you connect these computers to the LAN and then mounted these each hard drives as a folder onto one computer. This way, this way, when you go to a folder, the subfolders are numbered from 1 to 100. The subfolders are numbered from 1 to 100. Okay, and basically, we can start storing the data in these folders. Do you think there are problems with it? What are the problems do you foresee with this? Oh, okay, let me explain again. You bought 100 hard drives, each of 1 terabyte, and you bought 100 computers parallelly and put one drives in each and then connected them over the LAN, local area network, and then on one of the computers you mounted all of these hard drives as subfolders. Now you have one folder containing all these 100 subfolders where you can store the data. Now do you see any problem in this? Searching, excellent. That is Anand's point. Searching is one such problem. Any other problem do you see with this? Tightly coupled with main. It's not tightly coupled with main because if main goes down, it does not mean drive 1, drive 2, drive 3 go down. Poonam is saying consistency. Yeah, please explain. That's a good point, but I'm looking for a bigger explanation. Srinivas says network failure. Excellent. In case network fails, then our data will be lost forever. Very good point. Vikas says failure of any disk. Good point. If so, generally what we used to do earlier is on each of these computers, drive 1, drive 2, drive 3, we would put our extra hard disk. Okay. Yes. Video is being recorded and shared. Video is being recorded and will be shared with all of you. No worries. Okay. Sabrish is worried because there is some power interruption happening. Okay. So no worries. The video is being recorded. All right. So next is Naveen's point is data may be tampered due to power failure. Excellent. Very good point. Okay. Anand is saying bandwidth of the network should be more. Good, good. So what Anand is probably hinting is that the network might choke because of the data transfer, right? All right. Yeah. So somebody is saying hard disk crashes. Yes, that's a possibility. But what we'll do is we'll put one more hard disk within these hard disks. So we'll buy 100 more hard disks and put it there. Any other? More usage of power. That is Puneet. Good, good. So 100, no, no. It is like this. We got 1 TB hard disks. So we got a total 100 terabyte storage. Now we can store our 100 terabyte of movies. So drive 1, drive 2, drive 3 will be having different data. Too much hardware, that is good. That is ratio. Identical copy of each. Okay. All right. Yeah. All right. So yes, the challenges here are my summarized challenges. First one is there could be failure, network failure, or the whole computer might get crashed, against which such kind of systems not uh, are not comfortable with. These kind of systems cannot handle the failure of a particular node. They can handle a failure of a hard disk if you just place a RAID, redundant disk, with another one. Where one hard disk fails, there is another hard disk. So, but in case there is a network failure or the computer shuts down or one node's LAN cable has come out, in those cases it cannot sustain that. Next problem is how would you distribute data uniformly? So you said that let's store all the movies starting with A in first computer and second computer, and B on second and third, and so on. But after a point of time, you realize that all the movies which are starting with A are too many. Okay, so you might have to dedicate 15 nodes just for A alphabet, and to manage that will become your hassle. Every day you will be shifting the files from one node to another and maintaining the index. So it will become very difficult situation. Next is this best value for money? You bought 1 terabyte data. There could be smaller hard disks available in your network already. Okay. So why couldn't you utilize the existing resource rather than buying these high-end ones? What about increased accessibility? Right. So Anand's question is we can't say data will be evenly distributed maintaining identical copy. Yeah, we can't say the data will be evenly distributed, right? Now Srinivas is saying if drive 1 is lost, we will completely lose the data because we don't have duplicates. That is very correct. So in the old days, what we used to do is under one drive, we'll put another drive and we'll maintain one backup on each computers on the same computer. But that strategy is no longer enough because the node might fail. That's correct. Jyotsna's question is what does NAS or SAN means? NAS or SAN means network attached storage and or storage area network. And this is how we used to build most of the networks earlier for storing data before Hadoop came into play. Next is scaling out. Okay. What does it mean by scaling out? Scaling out means if tomorrow you need 200 terabyte storage instead of 100 terabyte storage, you should not you should not you should be able to add more hardware easily, and your existing data should get distributed onto the new set of hardwares, and that is called scaling out. Instead of instead of 1 terabyte I will buy two terabytes. Instead of doing that, you will basically say we'll just buy 100 more hard disks and we'll add into the network and distribute the data existing one. Scaling out becomes very difficult in the case where we have given, and that's when, so yeah, this is called that's when we say that we will use Hadoop distributed file system. Now, answering to Puneet's question, how is SAN coming into picture? SAN is coming into picture because storage area network or network as storage, when we used to build, we used to follow this kind of philosophy, which had its own problems. All right. Now, Puneet's next question is SAN or NAS still used along with Hadoop storage? So generally not. It's not generally used, but in some cases it is used. I met IBM recently. They were using the SN network along with the Hadoop, right? All right. We are now concerned with the network here. So Naveen, what's your question? What's your question? All right. Yeah. So how does Hadoop file system solves this kind of problem is what we are going to discuss. So Hadoop does a very good job of elevating these problems which we discussed. We designed a file system by mounting multiple hard disks in the network, and we face these kind of challenges as mentioned here. So to solve those problems, Hadoop comes up very brilliant file system, which is basically based on Google file system. Google built this kind of file system and published a paper. On that basis, Mike Caffarella and the other guy, they both built this Hadoop distributed file system. All right. Now let me just go into the SDFS file system. So the way Hadoop cluster has been built is there are two kinds of nodes in the HDFS. There are two kinds of node. One is name node, singular node, or we also call it master node or admin node. Okay, admin node, master node, name node. There is a single node in the whole network, and this node is responsible for noting down where is your data. As we talked about in our architecture, what was missing is an index so that we can find where is our data. Therefore, to solve that kind of problems, they 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 said there will be a node who will know where is the data, who will maintain the file system. Okay, so so all of the metadata, say what is the file name, what is the folder name, and all of that will be maintained by admin node or name node, and actual data will be stored by different type of node called data nodes. Okay, data nodes will be storing your actual files, while name node will be only noting down that this file is on this system, that file is on that system, and so on. Okay, now admin node or data node, both of these nodes are basically processes on your machine. They are just another programs on a machine running on different ports. They are catering to different network ports, which means you can connect to them at any point of time and then get your work done. So you have got name node, you have got data nodes in your network. Data node store the actual file which is inside the file's boundary, and the admin node store the information about the folder, file name, and permissioning and other things. Okay, so that if you have to have if you want to know where is your file, all you need to do is go to name node and ask. All right. Now I will not answer your question for the next 5 more minutes. I'll just complete few things. Probably you will get answered by yourself. Next is every file which you're storing in HDFS is broken into pieces called blocks. Okay, so the whole file is not stored just as is. It is broken down into blocks. The block's typical size, earlier it used to be 64 MB, now it has grown to 128 MB. You can also customize and configure this size and also change the size of the block at any point of time. Hadoop provides you that API. So basically the whole file is broken down into pieces, just like when you have to fit in things. If you have to try to fit in a bigger block in this jar, you will not be able to fit that one, but if you have to fit the smaller particles, it is easier. Similarly, that's the same reasoning why the whole file is broken into 128 MB blocks and then distributed into the network. Make sense? This helps us fitting big files into smaller hard disk. That means you can actually have a big file of 5 terabyte size. Okay, even though you have only hard disk of 1 terabyte, because this file will be internally broken down into blocks, each of 128 MB, and distributed into the network. Make sense? Also, when we are scaling up, when we are adding more nodes, the data transfer from one node to another becomes very, very easy, right? Also, it distributes the load to multiple machines. We will talk about it soon. Now, there's something called replications. Each block of 128 MB is copied twice, meaning there are total three copies of the same block. Okay, so if you are storing 1 terabyte data, it is going to consume 3 terabyte. But good news is it is configurable. Okay, you can say that this data is not important to me, just keep its 2 copy rather than 3 copies. Or in case your data is very, very important, then you can say that here is my file, can you change its replication factor to 5, because this file is very important to me. Okay, so each each file is broken down into blocks, and each block is copied that many times, n number of times, meaning replica number of times. If there are 3 replicas, it is copied thrice, and so on. Okay, now name node knows that this file was broken down into these many parts, and these parts or blocks are existing on these computers. So whenever you want to access the file, you go and ask name node, and name node will give you the details about data nodes containing your file. Okay. Next is in case one node fails. In case one node fails, so the lost blocks, the blocks that get lost because of the node failure, will be having some other copy, right? No two copies, no 2 copies of one block are stored on the same node. When I say node, node means a computer. Okay. In case a node fails, then we start copying the data. We start bringing the total number of backup copies to the same label which was promised. If by default it is 3, you can configure it. So if there was a block which there was a file which had 3 replicas, and on one node went down. So all the blocks that got lost here will be replicated using other existing node containing the same data. So that is how the replication work. Now you can see that. Now the next question you would have is, if everybody is accessing name node, the name node is going to get blocked. In this diagram, it shows that user is accessing name node is bringing data from data node and giving it. But that is not the case. This is not how HDFS work. Okay, because this way what will happen this way is name node will become bottleneck, and the whole purpose of distributed computing is lost. Okay, because if one particular node is your bottleneck, that means we haven't solved the problem. Next is, this is the real this is the way HDFS actually works. The user talks to name node or any of this via client driver, whereby user will issue commands like ls, copy my file, push my file, upload my file, and so on. And the moment, so the way it happens is user asks client driver to do something. Client driver goes to name node saying, "Hey, I want to add one file," and name node says to client driver back, "Then you don't talk to me anymore. Here are the details of the data node. You just go to the data node, get your data, and thank you very much." So this is how it happens. So if you want a file, you generally go to name node and say, Get me this file." So name node, instead of giving you the file, name node will give you the locations of the blocks, and your client driver is supposed to read it by itself. Similarly, when you're writing the data into name node, the client driver the client driver will ask name node that, "Hey, I'm interested in writing this file. I'm trying to write this file. Can you tell me which data node should I go to and write?" And name node will tell you that these data nodes are free. Can you go and write your data first block in the first data node, second block in second, and so on. So name node will provide all of that scheme to client driver. Sounds good? Now next question arises that, so here is the same architecture again. You have got data nodes, data node 1, 2, 3, 4, and these here are called blocks. They are inside each of the data nodes, and they are being replicated. The moment one node goes down, it copies to another one, and so on. Or I would write the data to one node, and that will start replication to another. So that is how it happens. Okay, and every time client does anything, say client is trying to read the data, it will go to name node, get the metadata, and then read it. Similarly, when client is trying to write it, I will ask name node that, "Can you tell me how many blocks should be there for this, and which all machines are free?" And then client will go directly to that node and do the write. All right. So the same diagram being explained here, client comes in to write the data, goes to HDFS, then it talks to the name node says that go to the data node, start writing, data node starts replicating the block, so to create the backup copies, and once it is done, once all the file is stored, it goes back to the name node saying, "I'm done with writing, can you commit the file?" So this is the general workflow, and similar is the file read. Okay, so the device division of file is done, slicing the file into blocks is done using client library. All right, so this is how it is. Next is the metadata is the details of metadata is like, metadata contains list of files, list of blocks, and data node for each block. Along with this information, it has access time, replication factor, and file size. All of this is part of metadata. And The transaction log is stored in the disk. All right. So these are the other components in the Hadoop ecosystem. We'll talk about them in a minute. But all right. Also, one more thing is there is something called secondary name node, because if you see here the diagram here, the name node is still something, a single point of failure. In case name node goes down, nobody will be able to access data node. That is why high availability name node is created, and that is why the secondary name node comes into play. Secondary name node is just the mirror of name node, which is always available to you. Okay, secondary name node is always available to you, uh, to everybody actually. Any changes you do to name node tells the secondary name node. Similarly, any changes data node tells to name node, data node also tells it to secondary name node. Okay, this way there is always a backup, and in case you set up the high availability and node goes down, it will immediately be replaced by the secondary name node. All right. Now Puneet's question was, so SAN would be storage. So SAN may be or may not be the storage for each data node. Okay, I had waited for this question. So the data node may or may not store on the SAN or network attached storage. Why? Because the data node as such, it will not be efficient if it tries to write to the remote. Okay, so generally it is not preferred to use virtual hard disks or use a remote file system for data nodes. So Rubin says that, so this means that admin node only contains the detail of the data node under it. So admin node knows everything about metadata. Probably you got the answer by now. Does admin node maintain hashtags? What is hashtags? Do you mean Twitter hashtag or do you mean hash values? MD5 hash or something? How to break the data into chunks? So the data is broken into chunks by client library automatically, and breaking the chunks is very ruthless, meaning they are all 128 MB except for the last block, which is smaller. If the backup node fails, then we can retain the data. Backup then if the backup node fails, then can we retain the data? So you got the answer, right? So in name node, there will be something called secondary name node having the backup, right? So in case the name node fails, we have everything in place. Yes, Jayprakash's question is, can we change the replication factor for different data separately? Yes, you can change the replication factor for each file separately. Okay, there is a Hadoop command in which says minus set rep. Okay, also go to the forum. We have mentioned exact strategy of changing this. All right, so that is one way. Jyotsna's question is, if you want to store only two copies, yes, you can do that. But remember, it's a distributed file system. In case, so the whole file is broken down into parts. So in case one data node goes down, it might impact uh, thousands of files. It might contain the blocks from thousands of the files, and hence all those thousands of the files might go useless in case the data block in case the backup copy is only one. If you have replication factor of only one, that means it's a big disaster we are waiting for. Suppose name node is down, then how will we? That is where the secondary name node comes into play, right? So Naveen's question is, that was Srinivas's question. Naveen's question is something like TCP/IP protocol. Yeah, it is mostly more like it also operates on SSH, and yeah, okay. What is the AC packet here? You mean to say here? AC packet means acknowledgement. This acknowledgement is given back to you saying your file write is successful, and that's when you go back to name node saying our file was successful, please note that down and commit it. Then onwards that file will be visible. In case in case HDFS client started the transaction, meaning it started the writing of the file, and told namenode that hey, I'm going to write the file, and it goes, and after that the process is killed. So this file which it was trying to create will not be visible, and that temporary data will be removed from namenode. All right. So what does it mean by client library? Client library is like a program on, say, when you have go to command prompt, any program you write, that's a basically client for some data, right? And the client library also means that in case you have to read write the data from HDFS, you can use the same jar, same library. Do we write queries to retrieve data from data node like no, we don't. So that is Sabrishi's question. Do we write SQL queries to retrieve the data from name node? No, we don't. But we will talk about Hive, where we will write queries and that will internally convert it into MapReduce. Okay. But here you simply say, get me this file, update this file, write to this file, or delete this file. Those are the only commands you send to each data nodes. All right. Thank you very much. A personal Google Chat window is open. Thank you, Anand. I'm so sorry for that. I was so busy looking at the questions. It was behind my questions window. How is the storage done for Hadoop if not using SAN? So storage is done right away, as in it will be using the local file system and local drive rather than SAN. Okay? Because if you try to do storage area network and again divide the data to network, then the whole performance is hit badly. And we don't require that much of a backup here because we already have backup replica factors and all. Okay. So for how many days we can access the cluster you will provide in the course? You can access the cluster for 50 days from the starting. In case you are not able to finish your work, we can extend that access to you, but you need to inform us for few days in advance. So you will get the video of this webinar within 6 hours. So Naveen's question. So Naveen, your question is there any chance? What about risk and quality? About what? Josna's question is, what about? Is there any chance secondary name node fails? If yes, then there is a chance of loss of data. So secondary name node generally doesn't. When you have a backup of two, it generally doesn't fail. Okay. Reason being that first, NameNode tries to keep itself free as much as possible by delegating the heavy processes to data node, such as writing the data, reading the data, and sometimes it also delegates everything. It keeps on delegating the things like dividing the data to client library and so on. and all of the metadata resides in the RAM. Okay, so in case both the nodes, primary and secondary, are down, then there is a chance of bigger failure. Yeah, that is correct. But that's a very, very rare. All right. So Naveen, I did not get your question. What about risk and quality? Vikas's question is: Pig script is option for non-Java professionals for MapReduce. Yes, that is correct. So Pig script tries to uh, Pig script is more like an SQL program which can be convert when run, it converts internally into MapReduce and run on the cluster. Okay, so that was Vikas's question. I know that for most of for you, it would not; those questions will not make much sense, but it's still. I would like to answer the questions. All right, and yeah. So that's pretty much from my side. If you have any questions, feel free to connect with me. The upcoming course is here. This is not the one. So these are the upcoming courses: 18th April and 25th April. So if you are planning for morning, then you can join the 25th April one, and if you're planning for evening, then you go for 18th April. Anand's question is: Are there any challenges being faced by HDFS currently? Challenging challenges in the terms of technology or competition. So as with the technology, all of these need to keep on improving all the time. And probably the bottleneck of name node is one which is bothering everybody. Okay, as even Jyotsna or Poonam has pointed that out, that in case both of these nodes go down, then it will be a big risk. Other than that, HDFS is actually fairly stable. And we don't have any other similar competing file system right now. Naveen's question is: when we think of important data, then Hadoop will be able to handle. Yeah, that's correct. Important data. Okay, so you mean to say, Naveen, let me now understand. Now I understood the question. So he mean to say that the when we have important data, will it we should we Hadoop be able to handle it? Yes. Okay, it should be able to handle it, and the risk and quality both are very well provided by HDFS actually. Okay, the backup, this replica factor makes it very, very important and easy for backup and disaster recovery. So Puneet's question is: what about security of the data? So you could do multiple things. You could actually encrypt a file and put it in the file system, but HDFS doesn't support encryption on the block level. Okay, so you can encrypt a file and then save it. Just that whenever you are accessing such kind of files, you will have to download the whole file and then decrypt it. Okay. In case of primary and secondary name node get failed, then how to map the blocks which are on different machines? That will be impossible to map the nodes. In those cases, you will have the data loss. That was Vikas's question. Good. All right. And with respect to security, HDFS supports Kerberos authentication and authorization, and you can use Kerberos, and by default the whole thing is protected with the Unix credentials. All right. So Jayaprakash's question is: Cassandra also include MapReduce in storing, so it is a competitor? Not really. Cassandra only stores the data which is in the format of table, so it is not really a competitor for HDFS. It's just a data store. All right. Puneet's question is, how secure is our data? So I think I have answered that question. All right. So if you have any questions, you feel free to drop by. I mean, send an email and okay. So yeah, if you have 2 more minutes, I can just go over the whole ecosystem. So we have main component, we have which is HDFS. Then we have something called Yarn. Yarn is the resource manager for computation. And then we have MapReduce, which does the computation, and we have Spark, which do the computation. MapReduce is good for batch processing, while Spark is good for real-time processing. And there is no SQL database data store. We call it data store because it does not have any SQL. Okay, it is basically for storing billions of rows and billions of columns. And the we have Hive is the SQL interface which can query the HDFS as well as HBase, or it can query the uh, other data stores as well. Then we have Piglatin. Piglatin is essentially similar to SQL and similar to Hive, just that it's a new form of language which is very well designed from bottom up, keeping distributed computing in mind. Next is Mahout. Mahout is a machine learning library. As we showed you the recommendation example, Mahout has those kind of algorithms which quickly generate very insightful and meaningful insights into data. And when you have a big project, you will be using more than 3, 4 components out of all of this, and that's when you use Oozie. If you want to import data from a relational database, you use Scoop, or you want to export the data to MySQL or any SQL server, then you use Scoop. If you want to import the data from unstructured sources in real time, then you use Flume. And whenever you are building a project, you will be using more than 2 components of this whole ecosystem. And when you want to tie them up together, you will be using Oozie. All right. So this is a very quick overview of what is Hadoop and big data. I hope you found it you found it useful. And so Vikas says Spark still has so many issues. Yeah, it is comparatively newer, so there will be issues, but it's fast. Sabri says that big data and Hadoop introduction is available in no big. Is it? Yeah, this is the same slides which I'm going through right now. There'll be minor differences. Puneet's question is, so it is not like each and every component is suited for every project. Not really. You generally say that okay, these are the things I'm going to use. Jayaprakash says that in Mahat, do we have to write algo or just be using its algo? You will be just using its algo. You'll not be writing algorithm in Mahat. Mahat is just a library of algorithms. So skills of big data analytics, a little bit of statistics and little bit of analytics knowledge is important. Plus Hadoop knowledge is important in this. Okay. Depending on the project, we use the required component. That is very correct, Puneet. So you can actually appear for any of the certificate, be it Cloudera or Hortonworks, or in my opinion, you don't require any certification. But because most of the companies are not really asking for certification, they are just writing in the job description saying that we need certification, but in reality, they don't. Okay. So, but if you are planning to write for certification for Hortonworks or Cloudera, go ahead. Our course has been staged so that the curriculum is covered. We cover all the products in that slide. Yeah. All right. All right, so that's pretty much from my side. You can, those who have signed up for the course, they can go to the LMS and finish the quiz. And since I had to rush through few things in the last, do not worry, we can cover it in the next session as well. Okay. If you have more questions, feel free to drop me an email anytime. Okay. Yes, we cover all the products in the last slide, plus one more called Zookeeper. Okay. So out of big data analytics and data sciences, a big data analytics will be easier. And it all depends on the course. Which course are we talking about? Who is giving that course? Because there is no single standard that defines that big data analytics will contain these components. Okay. So if you are planning for books, go for Hadoop Definitive Guide. That is good. And Anand, that is Anand's question. So yeah, you should go for the definitive guide on Hadoop. Okay. So thank you, Naveen. You find it nice and educative. I'm happy. All right. So any questions for me anymore? We are already running 18 minutes late. Which are the best languages to learn for becoming data scientist? In very, very simple and rash words, the language you should learn, Robin, is probably the Python because that is suitable. I have gone through many products and I realized that Python is the one language which will be good enough for any data scientist. And basics would be sufficient. You don't have to go into the details of the language. Okay. Jayaprakash's question is nowadays Hadoop MapRed is used or Spark is used more. Both are being used parallelly. Okay, but Spark is yet to get that kind of acceptance, while Hadoop batch processes are in production anyway. Thank you, Sabris. If you find this session very fruitful, yeah, my direct contact number is 9538 998962. Okay, but I would, since my connectivity is very poor, I mean, a better thing would be if you call on any of these numbers. That will be better because my connectivity is bad and I feel really, really awkward these days. I've just shifted the place, so that is why. Okay. So right now that is the reason, and in case there's a question we can do the hangout right now or I can give you a call. All right, that would be better because my VoIP works better than my landline. So first question from Sabris is that is it suitable for BE computer science student? Yes. Thank you, Anand. I'm happy that you find the session wonderful. I'm happy. I look forward to see you. And Sabris's question is where employer takes freshers for big data and Hadoop. So people, I mean, as of now, the people are taking the candidates with the experience in SQL. When they look at big data experience, they expect the people to know basics of SQL and little bit of Unix and little bit of programming. Okay, so if you are fresher, it would be a little tricky thing to get into big data because a lot of people are expecting these kind of experience as well. Okay, yeah, just use that Puneet. Uh, if you want to talk, you can drop your number. I'll call you back because I can give you the number, but my number will be mostly out of reach. I'm having these telephone issues these days because I live on 17th floor and there's no connectivity there. So that is a little bit a problem, Puneet, for me. Okay. My number is there in the last slide of this one as well. So this is my number, but don't use this one. Instead, okay, use these two numbers. Okay, so somebody else will respond to them. You can tell them that you want to talk to me, and then I'll call. Okay, so this is personal but not reachable these days. This one, so use these two. Okay. All right. Thank you, Poonam. I look forward to have more interactions. So I'm happy that you found this session helpful and knowledgeable. Thank you, Sagar. Thank you, Jyotsna. All right. Yeah, you go to my blog. There you will see. Go to my website, nobigdata.com. There you will see the blog, and you will find a few nice, helpful things over there. Thank you, Srinivas. Thank you, Naveen. Okay. Thank you, Sagar. I'm happy that you learned things. You found it useful. I'm really happy. So I'm in Whitefield, Puneet, in Bangalore. So you can drop me an email at any of the email you send. It comes to me actually. I keep a copy of everyone, and yeah. So reaches will be one, and you can actually say Sandeep at No Big Data is my email ID. All right, Vikas. So all right, Sandeep at No Big Data is the email ID. I'm Sandeep Giri. All right. I'm happy, Rishu, that you find it informative. Thank you, Puneet. I'm happy that your doubts are cleared. I'm really happy. Okay. So Vikas, you can get in touch with me on Sandeep at No Big Data. Okay, then we can discuss further. All right. All right. All right. It was a great session, a wonderful set of questions. I'm happy to have such a great candidate in my session, and I look forward to see you to have more interaction with you. All right. All right. If you have any questions, just drop me an email either at Sandeep at No Big Data or reach us at No Big Data will be better email ID. Good. All right. Thank you, Vikas. I'm happy that you found it awesome. Okay. Next webinar will be, I'm not sure when it will be, but the formal course dates on the same session what we have talked today will be on these dates also, and you can join us. There'll be only minor deviations to what we have attended, but the full sessions will be the session 2 onwards. You can join from 19th April and here 26th April. Okay. So rest of the sessions after second onwards will not be free and open sessions. All right. Thank you very much. I'm happy to have such wonderful questions in my class, and looking forward to more questions from you. And be active on our No Big Data forum. You can go here and you can say forum, and there you can keep on asking your questions. We love to we love to answer all the questions. Okay, so you can keep on asking the questions there, and I will generally go through this and will reply all of them. Okay, see, see you, Naveen. Have a good day. Bye, Jaiprakash. Bye, Anand. Bye, Jyotsna. Bye, Kamruddin. Bye, Naveen. Bye, Poonam. Bye, Puneet. Bye, Rishu. Bye, Ruben. Bye, Shabrish. Bye, Sagar. Bye, Srinivas. Bye, Vikash. All right. Bye bye.